I'm Gabriel. I'm a PhD student at UC San Diego. I'm currently researching in the lab of Mitch Brandenburg at the La Jolla Institute for Immunology. And I'm doing my thesis on what are called mucosal-associated invariant T cells, which are a very specialized type of T cells, which I'm very interested in. And we think they have potential to actually be some of what we call off-the-shelf therapies for a number of certain diseases that we want to look into.
Before you got here at UCSD, I'm where you lived in Chile?
Yeah.
Yeah.
So before I came to the US, I studied at the University of Chile. I did my undergrad in a career that's called engineering and molecular biology. And before that, I went to a high school downtown, in downtown San Diego.
How did you get interested in your research that you're doing now?
I think I got interested because when I was in high school, I felt like I really wanted to do something that could potentially help people. And I think research just caught my interest because it was about developing new things and doing stuff that can actually, like prevent disease, cure disease, or, like just make things easier for people. And I got the opportunity while I was doing my undergrad to actually go from what was called like the School of Science to the School of Medicine to do my thesis. And there I actually was working on a specific disease, which is gastric cancer. And gastric cancer is one of the most prevalent cancers in Chile. So that was something that was really interested in me because I wanted to actually do a research that could have an impact
Yeah.
in people's lives.
In understandable terms for high schoolers, could you describe some of your specific research papers that you've published?
For my undergrad paper that we published that was actually my thesis, my undergrad thesis. It was about gastric cancer patients in Chile and how they have a higher prevalence of a specific type of cell, very similar to these mucosal-associated invariant T cells. These are called invariant natural killer T cells. And we think that the reason that we started seeing less of these cells in the blood of patients is because they're actually acting in the cancer. They're actually functioning through the cancer. That was very interesting because this could mean that if we could give more of these cells to patients, maybe that could be a way that they could fight cancer better. Follow-ups to that research is kind of what do we do with this information and how do we actually project this clinically? How can we actually start thinking about, therapies, start to think a little bit more about using the mechanisms that we know are involved in these types of cancers. And I think that was very interesting because when we think about cancer immunology, there's a very straightforward thing, which is called neoantigens. The cancer mutates, it generates these new strange figures which are foreign to the body, and then the body attacks it. But what we found is that actually in this particular case, there seems to be another mechanism that's involved, and this is directly involving these iNKT cells, or invariant natural killer T cells. And we think that if we use that system, which is basically a system of biological stress, is how your body says that there's stress, there's something that is wrong going on, we can actually use that system to potentially tell the body, yes, actually something is going on and you need to respond to it. And I think that's what's interesting about just cancer immunology is that the whole idea is to use your own body to combat the cancer.
What have you enjoyed most about doing research on this gastric cancer? And
Well, I think now, for example, I've transitioned to kind of more basic stuff. So I started with something very practical, like a specific disease and a specific situation. Now I'm transitioning to another cell type, which is these mate cells, and more in the context of, let's say, infections and stuff like that. But what's interesting is that you can use this information, you can use everything that you learn from infections, from autoimmune diseases, to actually apply it and think about it in other contexts, like in the context of cancer or other diseases. So I think is what's been really interesting for me is being able to have the opportunity to dive into this in a more, let's say, basic or more fundamental research of how these mechanisms work. It's more detailed. There's a lot of very small pieces that you see moving. But what is very interesting is that you can apply all that. You can use all of that information to actually start thinking about therapies, thinking about new things to develop, thinking about new drugs to generate. So I think that's what's been very interesting, especially arriving here at UCSD.
what has been the biggest challenge you face?
I think one of the biggest challenges that I had to overcome is just the level of detail and the level of precision that you need to have when you're designing experiments, when you're thinking about experiments. Sometimes you can think, well, this is a very simple question. I'll just take something out, see if it's important because it's not there, and then just look at the effect. But what happens normally is that it's not just one element which is necessary. Multiple times, what you're seeing is that it's a whole orchestration of different situations that need to happen. And being able to face those challenges, especially using new technology, using techniques that are much more complex, I think that's a big challenge, but at the same time, it's very rewarding to actually get an answer and to be able to say, yes, this is how it works. This is why it works like this, and I can prove it because I have these controls, because I have these other circumstances. I think that's just very powerful once you get to discover something.
Which person or mentor in your field has made like the biggest impact of you, like on you? Like who has like helped you get to where you're at today?
I would say my current mentor, Mitch Cronenberg. When I was in Chile, it was very funny because all that I was reading about was about his research. Like every time I looked something up about either NKT cells or other types of cells, his name would always come up. And I just had the idea one day that I was just going to write to him. So I wrote, and he said, like, yeah, come here, come to my lab, let's do stuff together. And we just started writing, we started talking, we wrote some grants together, and then everything just came from there. And now I'm in his lab, I'm finishing my PhD, and I think it's just been fantastic working with him.
What plans you have like after you get your PhD?
I'm planning to look for, or basically continuing the research career, which means after you get your graduate degree, the idea is that you do what is called a postdoc,
Mhm.
and it's basically this transitioning into like a more professional ambience. But at the same time, that's the last step before you actually become a professor. My objective right now is to be able to at one point go back to Chile, being able to be a professor there. But for that, I need first want to do more research, bring new techniques, bring new ideas, and just accumulate all that so I can bring it back. So that's kind of the plan right now.
Do you have any advice for people who are like currently high schoolers who want to get into research but like don't know like how?
I think my advice would be to search, like start looking into things to do, like looking into the opportunities that exist out there. Sometimes it's hard, sometimes you don't know anyone, and sometimes you don't have the networks to do it. But I think there's good opportunities out there to do things. I personally have been supervising a bunch of different either high school students or college students, helping them in the lab. They don't necessarily need to know anything, but their curiosity, I think that's the most important part, to be curious, to be interested, and actually wanting to, like put in the work, learn something, and with that, being able to discover something.
What traits do you think define a great like researcher and like specifically your field?
I think potentially there's a lot of things that are relevant, but I think one of the most important is the drive. Like how interested are you really in this? I've received like different people in different contexts, and I think it's always different when there's some motivation, when there's the interest of actually achieving that point. You don't necessarily need to have that right away. You can develop it. I've seen people starting, like very lazy in the lab. Maybe they'll come, maybe they won't. But then as they get interested, everything changed. And you can see that because, well, the techniques and all that is important. But that comes, and it will come easier if you actually have the drive to get to that point. So I think that would be the most important thing that I would look into someone and just try to see, is this person going to do well?
Different institutions have you worked at besides like UCSD? Where do you think your field is expanding to? Like,
I think now what's happening, and this happened like during my time in Chile and like also my time here, cancer immunology used to be, like the black sheep. Like people were not interested in it. They thought it was, like something, let's say, anecdotal, not so interesting. But once there was shown the capacity of what the drugs based on that can do, this is called immune checkpoint. These are drugs that can actually save a lot of patients. And the people who discovered this mechanism and actually got this, they won the Nobel Prize a couple of years ago. And from there, the field has just, I don't know, explode with a lot of people interested in this, a lot of people re-interested in immunology. And I think the other thing that's really been very impactful has been actually the pandemic. We've seen like people nowadays know very, like fundamental terms of immunology, like antibodies. They know what a vaccine is. They know they know what an adjuvant is. All of these things that we normally not talk about, but we always had as a concept as immunologists. So I think nowadays people are really appreciating what that means. And I think nowadays the whole idea is to bring the field closer and closer to the
mhm.
clinic. So transitioning from bench to bed.
Thank you so much for your time and everything. Really appreciate it and taking time out of your day to talk with us.